Hello, everybody. My name is Tanner Ellison, and today I'm going to be presenting sustainable aviation fuel as part of the biofuel video project. So, first question is, what is sustainable aviation fuel, also commonly referred to as SAF? We're going to answer that question and a few more. More likely, how does it compare to the conventional fuel methods that are currently being used today? And how can we overcome the challenge of implementing SAF, and why isn't it yet widespread? So let's first discuss the life cycle of sustainable aviation fuel. It first goes to collection from feedstock and cooking oil and the other waste products of the agricultural industries. It is then sent to be converted at a petrochemical facility, which increases its combustion efficiency and it dries out any impurities that may have been present once it was collected. It then moves to the blending phase, which SAF is blended with a mix of traditional jet fuel. It is usually a 50-50 mix. However, Exxon is working on developing a variant, which is a 20% traditional fuel blend and 80% SAF. So it's important to note that SAF is a additive, not necessarily a fuel on its own, as the name might imply. After this stage, it is then sent to the fuel stocks, in which it is used in commercial airliners and also just other commercial aviation aircraft. So 80% is the big picture number here, and that stands for the total reduction in emissions compared to the standard aviation fuels. Commercial aviation is one of the most polluting industries on the planet, and it produces billions of cubic tons of CO2 and leaded fuel waste being burnt a year. Traditional aviation fuel is quite toxic as it is leaded, and it is about 110 octane, so it pretty much evaporates into a gaseous form immediately. Let's compare the two. Traditional fuels are a petrochemical. They are made from liquid petroleum. They are unblended, so they are just a straight raw fuel pumped from tank to engine, and it is the lowest cost option. Sustainable aviation fuel, on the other hand, is about 4 times more expensive than the traditional fuel currently available. It's not commercially worldwide. We'll get into why in a minute. And it has to be blended, as I mentioned previously. The contrail formations, which you may notice at the bottom of each, refers to the bubble of drag behind the engine. So a higher contrail formation is less efficient, and a lower contrail formation is more efficient. That is part of what adds to that 80% reduction in CO2 emissions with SAF. So some current hurdles with sustainable aviation fuel. They basically boil down to two main issues. The first being supply and demand, and the second being cost, and they are directly related. Supply and demand, even not considering the supply chain issues that have still been present from the pandemic, the main barrier to SAF is the basically availability of the fuel. So budget airlines and ports of less affluence, so places in, let's say, East Asia, Indonesia, um, India, Africa, some of the more impoverished places on the earth, they really can't afford to eat the cost that comes with implementing SAF because, like I mentioned, it's about 4 times more expensive than the traditional variants. So they really do need a basically they need the fuel to become more efficient and the production of it and more available, which we'll mention now. So the first priority, like I said, needs to be to increase the efficiency of recycling the food stock from our agricultural industries into SAF. And the second needs to be regulation on our part to force the fuel markets to turn away from the cheaper alternative of leaded fuels and to adopt the SAF blends to increase supply and by increasing demand and then to lower the cost. So, just to kind of wrap us up, let's just cover where we are at currently versus where we need to be. So, this is a graph from the Institute for Energy Economics and Financial Analytics. The blue shows the forecasted growth for the production of traditional jet fuel and relative to the emissions over time. And red is where we need to be. The blue area is the difference between them. We want a minimized area as much as possible. And as you can see, it only seems to be expanding. So, the implementation of SAF definitely needs to be it needs to be a priority as we continue to produce millions of metric tons of CO2 each year, and it only seems to be increasing at a linear rate. Thank you for your time, and I hope this was educational to you and informative on sustainable fuels and a possible alternative for the aviation community. Thank you.